For decades, Pluto held a special place in our hearts and our solar system. It was discovered in 1930 by Clyde Tombaugh, a young astronomer at the Lowell Observatory in Arizona. This discovery captured the world's imagination. Pluto, a tiny world billions of kilometers away, became an instant celebrity. Schoolchildren memorized its name alongside the other 8 planets. Pluto was a symbol of exploration and discovery. It represented the vastness and mystery of our cosmic neighborhood. We knew so little about this distant world, shrouded in darkness and ice, yet it held a powerful allure, a promise of secrets waiting to be unveiled. The year 2006 marked a turning point in our understanding of the solar system. The International Astronomical Union, the recognized authority for naming and classifying celestial objects, decided to redefine the term planet. This decision was driven by new discoveries and a desire to bring clarity to our understanding of the cosmos. The IAU established 3 criteria for an object to be considered a planet. First, it must orbit the Sun. This criterion was straightforward and uncontroversial. Second, it must have sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium or nearly round shape. This meant that the object had to be massive enough to pull itself into a spherical shape, a characteristic of planets. Third, and most importantly, it must have cleared the neighborhood around its orbit. This last criterion proved to be the most significant for Pluto's status. It meant that a planet must be the dominant gravitational force in its orbital region, effectively clearing its path of other objects. Pluto, unfortunately, did not meet this last requirement. It shares its orbital region with numerous other icy bodies in a region known as the Kuiper Belt. This failure to clear its neighborhood ultimately led to Pluto's reclassification as a dwarf planet. Even before the IAU's historic decision, astronomers were busy unraveling Pluto's mysteries. Advanced telescopes provided clearer views of this distant world, revealing its icy surface and its large moon, Charon. However, it was the dawn of the space age that truly revolutionized our understanding of Pluto. In 2006, NASA launched the New Horizons spacecraft on a mission to Pluto and the Kuiper Belt. This ambitious mission aimed to provide the first close-up views of Pluto and gather valuable data about its composition, atmosphere, and surrounding environment. The data sent back from New Horizons was nothing short of groundbreaking. It revealed a world far more complex and intriguing than we ever imagined. Images of Pluto's surface showed a surprisingly diverse landscape with towering mountains, vast plains, and evidence of ancient glaciers. The mission confirmed the presence of a thin atmosphere and even hinted at the possibility of a subsurface ocean. The discovery of the Kuiper Belt in the early 1990s played a crucial role in Pluto's reclassification. This vast region beyond Neptune is home to countless icy bodies, remnants from the early solar system. Pluto, it turned out, was not alone in its distant realm. Astronomers began to discover other objects in the Kuiper Belt that rivaled Pluto in size and composition. Eris, discovered in 2005, was particularly significant. It was slightly larger than Pluto and possessed a similar icy composition. This discovery raised a fundamental question. If Pluto was considered a planet, shouldn't Eris and other similar objects be classified as planets as well? The IAU, faced with the prospect of potentially dozens of new planets, chose to redefine the criteria for planethood. This decision, while controversial, was driven by a desire for scientific accuracy and a more nuanced understanding of our solar system's structure. Section 5. A dwarf among giants. Understanding Pluto's new status. The term dwarf planet might sound like a demotion, but it's important to understand what it truly signifies. Dwarf planets, like Pluto, are celestial objects that share many characteristics with planets. They orbit the Sun and are massive enough for their gravity to pull them into a spherical shape. The key difference lies in their orbital dominance. Dwarf planets reside in regions of space where they share their orbits with other objects of comparable size. They haven't cleared their neighborhood like their larger planetary counterparts. This new classification system, far from diminishing Pluto's significance, highlights the incredible diversity of our solar system. It acknowledges that the cosmos is not always neatly categorized and that there's still much to learn about the celestial tapestry that surrounds us. Section 6. The Aftermath. Astronomers and the public react. The IAU's decision to reclassify Pluto sparked a wave of reactions from both the scientific community and the public. Some astronomers supported the decision, arguing that it reflected a more accurate understanding of planetary science. Others expressed disappointment, feeling that Pluto had been unfairly stripped of its planetary status. The public reaction was even more pronounced. Pluto, once a beloved member of the planetary family, had been demoted. Many people felt a sense of nostalgia and loss, having grown up learning about the 9 planets. The debate over Pluto's status highlights the emotional connection we have with celestial objects. It reminds us that science is not just about cold, hard facts, but also about how we interpret and relate to the universe around us. Section 7. New Horizons, a New Perspective. The New Horizons mission, launched before Pluto's reclassification, took on a new significance in the aftermath of the IAU's decision. It provided a timely and detailed look at this newly designated dwarf planet, revealing a world far more complex and dynamic than previously thought. The mission's findings challenged preconceived notions about Pluto and the outer solar system. The discovery of vast nitrogen glaciers, towering mountains made of water ice, and a possible subsurface ocean painted a picture of a world teeming with geological activity. New Horizons data continues to be analyzed, revealing new insights about Pluto's atmosphere, its interaction with the solar wind, and the processes that shaped its unique surface features. Section 8. Pluto's Legacy, Expanding Our Cosmic Horizons. Pluto's journey from planet to dwarf planet is a testament to the ever-evolving nature of scientific understanding. It reminds us that our knowledge of the cosmos is constantly being refined as we make new discoveries and develop new technologies. Pluto's legacy extends far beyond its classification. It has inspired generations to look up at the stars and wonder about the mysteries that lie hidden in the depths of space. It has fueled our curiosity about the origins of our solar system and the possibility of other worlds yet to be discovered. As we continue to explore the cosmos, Pluto's story serves as a reminder that the universe is full of surprises. It encourages us to embrace new discoveries, challenge existing paradigms, and never stop questioning our place in the grand scheme of things.